Welcome. This is an introduction to probability and the addition rule. We're basically just going to go over some vocabulary and do a couple really simple probability problems. All right, so these are some of our vocabulary words that we'll be learning about in this lesson. Probability, sample space, equally likely outcomes, theoretical probability, geometric probability, trial, simple event, compound event, mutually exclusive events, inclusive events, outcomes, events, favorable outcomes, complement, experiment, experimental probability, and one they don't have listed up here, Venn diagram. We'll be using Venn diagram with probability. Oops. Come on. There we go. And it decided to write in purple for the first two letters, probably because the last color I wrote in was purple, but I picked up a black pen. All right, so let's look at a little vocabulary. So you have some blank spaces in your notes that you can fill in, and just a little hint, the words are underlined. Plus, it may have you add in a couple little pieces of information. So probability is the measure of how likely an event is to occur. Each possible result of a probability experiment or situation is an outcome. The sample space is the set of all possible outcomes. An event is an outcome or set of outcomes. Right? So we have each possible result of a probability experiment or situation is an outcome. So for instance, if we're rolling a number cube, rolling a 1 is an outcome. Rolling a 2 is an outcome. Each event here is an outcome. Right? So an event is just an outcome, something that could occur when we do something. So when we roll a dice, an event that could occur is that we roll a 1. Another one is a roll of 2, or we roll a 3, etc. The sample space is a set of all outcomes. So this 1, 2, 3, 4, 5, 6, that's our sample space because that includes all of our outcomes. If we're spinning a spinner, blue is an outcome. Green is, for that particular spinner anyway, blue is an outcome. Green is an outcome. Yellow is an outcome. The sample space is the set of all outcomes, red, blue, green, and yellow. Okay, so outcome and event are really our synonyms, right? In a lot of ways. Sample space is just the set of all of the outcomes or all the events that could occur. So probabilities are written as fractions or decimals from 0 to 1, or as percents from 0% to 100%. Right? So impossible would be a probability of 0 or 0%. Certain is a probability of 1 or 100%. And then if something is equally likely to happen as not happen, we can represent that as a decimal, 0.5. We can represent that as a fraction, 1/2. And we can represent that as a percent, 50%. Most of the time we'll only use decimals if we're actually given the probability as a decimal, and you'll see that in some later problems. Most of the time we'll represent them as fractions because it helps us see the favorable versus total, which is actually what we're going to learn about next. So equally likely outcomes, that's the next blank in your notes, have the same chance of occurring. When you toss a fair coin, heads and tails are equally likely outcomes. Right? So something that either outcome has the same chance of occurring. Rolling a dice, all the six-sided dice, right? Those 1, 2, 3, 4, 5, 6, those are equally likely outcomes. They have the same chance of happening. Favorable outcomes are outcomes in a specified event. Another way you can write that, and I'd like you to put that in your notes, favorable outcomes are outcomes of interest. It's not that they're better or worse than the other outcomes, it's just what we're interested in. So it's a favorable outcome if it's the one that we're interested in. So for equally likely outcomes, the theoretical probability, so theoretical means what should happen, versus an experiment, what does happen. Right? So we're looking at theoretical probability, what should happen. So for equally likely outcomes, the theoretical probability of an event is the ratio of the number of favorable outcomes to the total number of outcomes. Right? So theoretical probability for equally likely outcomes is going to be the number of favorable outcomes over the number of outcomes in a sample space. So we're going to write it as a fraction, and then we'll reduce if possible. Okay? So let's look at an example, and you have this example in your notes. We're going to look at two examples actually. So each letter of the word probable is written on a separate card. The cards are placed face down and mixed up. What is the probability that a randomly selected card has a consonant? Well, let's draw out our sample space, because that always makes it easier. All right, so I have P, R, O, B, A, B, L, running out of space, got more space over here. Okay, so here's our cards, and you can draw this out in the space that you have in your notes. And so each of these cards has a letter on it, and together all the letters spell probable. Right? We want to find the probability that a randomly selected card has a consonant. So we're looking for the probability of consonant. That probability is going to be we'll determine that by the number of cards with a consonant. So the number of cards with a consonant, those cards that have consonants on them, I keep wanting to say constant, probably because constant's a math word and consonant is an English word, are our favorable outcomes. Right? So these ones here are our favorable outcomes because we're interested in the probability that we're going to get a consonant. Out comes. Right, we're going to take the number of cards with a consonant over it and divide that by, or in the denominator is going to go the total number of cards. That total number of cards is our sample space. And that includes everybody, the ones that we're interested in and the ones that we're not interested in. All right, so the number of cards with a consonant on it, all right, so that's P, and that's R, and that's B, and B, and L. So there were 5 of them, right? So we have 5 favorable outcomes. There are 1, 2, 3, 4, 5, 6, 7, 8 cards up there. So the probability that we pick a consonant is just 5/8. Because there are 5 favorable outcomes and there are 8 total outcomes. There we go. Okay, so just put this one in your notes. And if you have questions on this in class, just ask me. I'm just going to go over, though, some basic concepts related to probability, and then we'll go over more concepts in class. Let's look at another problem, this one involving some dice. Right? So here, all of the cards were equally likely to occur, right? There is one of each of, we have 8 cards. Any one of them we could pick just as likely as the other one, right? And so our favorable were the 5 that had the consonants, and the total were all the cards that there were. And here we have a dice problem. Okay, so we roll 2 number cubes. These are all the possible outcomes. So they're color-coded so that you can see that for instance, a 2-1 and a 1-2 are not the same thing, right? Because the red die, for the 2-1, it was the red die that was 2 and the blue die that was 1. And for the 1-2, it was the red die that was 1 and the blue die was 2. So they're technically 2 different outcomes, even though they have the same numbers on it. So here you can see all the possible outcomes. So there are 36 possible outcomes with the dice, right? That's important to note. It's 6 times 6. Because each of the 6 numbers on one die could be paired with each of the 6 numbers on the other die. So that's why there's 36. We want to find the probability that the difference between the 2 numbers is 4. So we're going to calculate our probability by finding the number of outcomes with a difference of 4. That would be our favorable outcomes because that's what we're interested in. So I don't have the picture with all the different outcomes in your notes, but I have the problem in your notes. So just write down what I'm writing down above the equation here. So these are our favorable outcomes because we're interested in how many outcomes have a difference of 4. And 36 is the total number of outcomes because there are 36 different possibilities when we roll 2 dice. All right, so now let's look for the ones that have a difference of 4. So when we say a difference of 4, if I were to subtract one from the other, I would get 4. So and it doesn't matter which one you subtract first. So for instance, 1, 3 is not negative 2. It would be 3 minus 1, 2, right? So this would be a difference of 2. This would be a difference of, so I'll just put 2. This would be a difference of 1 over here. And this would be a difference of 3. Right? So we're looking for dice that have a difference of 4. So these are not favorable outcomes that I'm trying to erase and that are not seeming to go away. There we go. So for instance, these 2 dice, any day now, I circled them. Oh my goodness. I guess I must have hit the board with the marker while it was in my hand. And there we go. Now we don't have that silly line. So these 2 dice have a difference of 4, right? 5 minus 1 is 4. They're 4 apart. Let's see if there's any others. Well, 6 and 2, those are 4 apart. All the others in these 2 rows aren't going to be 4 apart. The numbers are too close. And there's no number that's 4 apart from 3 on a 6-sided dice. And there's no number that's 4 apart from 4 on a 6-sided dice because there's no 0 and there's no 8. Moving over, however, we see 1, 5. They have a difference of 4, and there wouldn't be any others. All the other ones are too close. And 2, 6. So we see there are 4 different outcomes here where the dice have a difference of 4 between them. So that means our probability of getting a difference of 4 is going to be 4 because there are 4 favorable outcomes over 36 because there are 36 total outcomes. Now that's not in lowest terms. We need to reduce that. Right? So they're both divisible by 4. So when we reduce that, our answer is going to be 1/9. So that would be the probability that the difference is 4, would be 1/9. Okay? We'll do some more problems in class, and then we'll look at some more concepts related to probability. Thank you for watching this podcast. Bye for now.